Within this lesson, we're going to learn how to multiply by 10, 100, or 1000. Here we're starting with the same factor of 7, and we're going to see what happens when we multiply it by 10, we multiply it by 100, or we multiply it by 1000. When we think of this first one, we're thinking of 7 times 10, or 7 tens. 7 tens is worth 70. The next one, we're thinking about 700s. 700s. 700s we write as 700, or 7 times 100 equaling 700. What does 7 times 1000 equal? Or 7,000s. How do we write 7,000s? We write it as 7000, 7,000. Continue to look to see what happens with these products as we multiply by a larger factor of 10 here. So we have 10 or 100 multiplied by 100 and multiplied by 1000. Look what happens to the products here. The number of zeros increases, where it is that we've increased this digit and the value of that 7 within the number by multiplying it by 10, multiplying it by 100, or multiplying it by 1000. One more time, we look at this here, 8 times 10. We know that it's going to equal 80, but let's look at it another way. I'll rewrite that 8 first. And then, is that 8 going to get larger or smaller? It's going to get larger. We're going to move it one place on over to the left. And then, so this is our 8 times 10. The 8 ones, if we multiply it by 10, is worth 10. So 8 of those ones equals 8 tens, and that's why we put 8 in the tens place. We have to put a 0 in the ones place, and that is our answer, or 8 times 10 equaling 80. Here we have 8.1 times 100, and if we're multiplying by 100, we're actually multiplying by 10 twice. So we're going to end up moving 2 place values. Currently, the 8 is in the ones place, where we have the 0.1, and that 0.1 there, 8.1, or 8 and 1/10. And so that is in the tens place. When we're multiplying by 100, we're not going to only move one place. If we had 8.1 times 10, we'd only move it one place. The ones would go to the tens place just as before, and the tenths would actually go to the ones place, because 1/10 times 10 is is worth a 1. And then so 8.1 times 10 is already 81. So here, when we're multiplying by 100, we actually have to move these digits 2 places. If we make this 8 here, if we only moved it 1, it would be in the tens place. But if we move it 2 places, that 8 is now in the hundreds place. And if we move the tenths not only 1 place, but 2 places, it is now in the tens place. What do you think we have to put here in the ones place? Is there anything to put there? We need a placeholder, and the digit we use for a placeholder is 0. So we have the number 810. 810. Thinking about it again, we have this 8 already, and 8 times 100 is worth 800. And that 1/10 times 100 is worth 10. So our product of is 810. Comparing that to our other answer over here of 8.1 times 10 was 81. We have 810 here. Here we're asked to solve 13.82, or 13 and 82 hundredths times 10. And we're going to end up using a place value chart here to solve this problem. First off, we're going to go ahead and place 13.82, or 13 and 82 hundredths into the place value chart. And then so I'll put the decimal point first. There's a 3 in the ones place. There is 1/10, and we have 8/10, and we have 2 hundredths. But what we're doing is we're multiplying by 10. And then so if I have 1/10 and I'm multiplying it by 10, 1 times 10 is actually equal to 100. And that's why it is that I move that that place over there and that digit over there. The 3 gets moved into the tens place, or 3 ones times 10 is equal to 3 tenths, or 30. 8 tenths also gets moved right on over. The decimal point comes straight down, and lastly I have to move my 2 hundredths, so that 13 and 82 hundredths times 10 is equal to 138 and 2 tenths, or 138.2. We have not worked on any problems where it is that we have multiplied by 1,000 yet. 27 times 1,000, or 27 thousandths. How do we write 27,000? 27,000. Let me try another one using a place value approach, 82 times 1,000. So I'm not multiplying by 10. If I was multiplying by 10, I'd only move each digit over one place. Here I'm multiplying by 1,000. So we're moving each place over 3 places. That 8 is no longer in the tens place, nor is it in the hundreds place, not even in the thousands place, but it's all the way over in the 10,000s place. It is in that 10,000s place. Its value is worth 80,000. The 2 gets moved over not only to the tens, hundreds, it actually is in the thousands place. And then to be able to get this into the thousands place, I'm going to place a comma, and then I need my placeholders, which is a 0, 0, 0. So 82 times 1,000 equals 82,000. Here we have another problem where it is that we are multiplying by 1,000. 218 and 3 tenths. We're using a place value chart this time. I'll put the 2 in the hundreds place, 1 in the tens, 8 in the ones, write my decimal point, put in 3 tenths, and I'm multiplying by 1,000. Sometimes it's easiest to look at the ones place and think about what happens to that ones digit when you multiply by 1,000. 1 times 1,000 is? Yeah, it's 1,000. So 8 ones times 1,000 is equal to 8,000. It moves 1, 2, 3 places on over. And each of these becomes larger as well. When we're multiplying it by 1,000, our numbers are going to end up getting larger or bigger. The 1 ends up in the 10,000s place, because 10 times 1,000 is 10,000. Same thing with the 2 here. And the 3, of course, for the tens place. Can't forget that. Moves over 3 places as well. We need a placeholder in the tens place, and we need a placeholder in the ones place. So our answer is 218,300. That product again, 218,300. So again, when you multiply by 10, any digits that you have there, when you multiply by 10, they actually get 10 times bigger. So this 1 in the ones place becomes over into the tens place, and that in that tens place actually goes to the ones place. 7 tenths times 10 being 37 there. When we multiply by 100, I'll give you one more example here, 2 and 8 tenths times 100, 2 times 100 already is 200. Each of these gets to be moved 2 places. So we have here 2 there, and then we also have 8 there, and we need a placeholder of a 0. Otherwise the 2 would not be in the hundreds place. 2 and 8 tenths times 100 equaling 280. If we multiply by 1,000, each of those digits actually gets to be moved 3 places on over. They become worth 1,000 times more by moving those digits 3 places over. 3 times 1,000 already is 3,000. And how do I get that 3,000 there? I copy the rest of the digits, the 8 and the 2, and I need a placeholder of a 0. 3,820. Where it is that we can take those steps to work out these problems, and we just have to think whether or not that's reasonable. When you multiply by 10, 100, or 1,000, of course the numbers are going to get bigger. Sometimes they're only 10 times bigger, 100 times bigger, 1,000 times bigger, depending on what it is that you are multiplying by.